Joining STEMmunity, we have Kathleen Higgins, an MD and PhD student at the Harvard Medical School and at MIT in the Weng Lab. Kate received a Bachelor's of Art degree in Chemistry and Biology at Williams College. Thank you so much for joining us today, Kate. Do you mind on expanding more about your educational and professional journey that's led you to where you are right now?
I'll say that I grew up in California, in the suburbs of San Francisco, in a neighborhood that's a little bit like where I guess you grew up in Cambridge. But I knew I wanted to see a little more of the country. So I went east to Williams College, which is a tiny liberal arts college in Western Massachusetts. And while I was there, as you mentioned, I studied chemistry and biology. But I didn't really know what I wanted to do next. And I decided to take 2 gap years in which I came to Boston and I worked in a lab at MGH and the Broad Institute studying mitochondrial disorders. And for me, that time was really formative because I got to know physician scientists. And I don't know about you, but I grew up thinking of physicians as being kind of, godly levels of smart. And I never thought I could measure up to physicians. And it was really getting to know physicians and physician scientists in the Boston area that made me feel like it was a challenging career path, but potentially achievable. So my 2 gap years are really transformative, and I decided to apply MD PhD all around the country. And I ended up settling right here in Boston. And I've done 2 years of medical school and a 6-year PhD is split between 2 labs. And actually on April 1st, so in about a month change, I'm going back to full-time medical school and resuming my MD. So for me, it'll be a 10-year program, which is a big block of time, but I really enjoyed the process. So it's been a good investment.
Thank you for sharing that. And could you please expand for our viewers what exactly you're doing in your MD PhD, what that is, and what you're doing in your current position right now?
Yeah, so the MD PhD is training which is specialized for people who want to become physician scientists. And I do want to say you don't need an MD PhD to be a physician scientist. There are a lot of really good physician scientists who just have an MD, and there are a lot of scientists who do really clinically relevant work who don't have an MD. But since I knew I wanted to do both, I thought this was the most efficient training path. So as part of the MD PhD, it's basically a med school sandwich where I split med school around the PhD. And for most people, it takes 7 to 9 years. I'm taking a little bit longer because I switched labs, but it's been a lot of fun. So I attend medical school just like any other student, but then there's this break in the middle where I do my research training just like any other grad student.
Okay, thank you. So I know you mentioned that you have a Bachelor's of Arts in Chemistry and Biology, and you also took a gap year to see whether you wanted to be a physician. And I guess moving a little bit before that, when did you realize that you wanted to pursue a career in STEM?
It's really, as long as I can remember, I've wanted to be some sort of scientist. And I think it really started with my parents, showing me Pod Wander under my dad's microscope. And I found that to be magical. And my parents had enough money to send me to some summer camps to kind of develop this interest. I'm particularly grateful to the folks at the Palate Museum and Zoo, which is a great opportunity to see different types of science, ranging from biology to physics, marine biology, ecology, really the full spectrum. And that was where the interest really solidified and took hold. And then as I continued through my training through high school and then college and grad school, I kind of refined that interest and started focusing on evolutionary biology as a part of science I'm excited about.
Thank you for sharing that. So, you mentioned that your parents' support played a huge role in terms of getting you interested or at least furthering your interest within STEM. Was there any particular person who inspired you or played as a support network in your career in STEM?
I have so many people I'd love to mention here,
Yeah.
but I'll keep it a little brief. I'll say that growing up, at the Paleontology Museum Zoo, Becky was really my role model. She was a young adult who was just developing her career in science. She's since gone on to become a professor at University of Nebraska. And she was so welcoming and she made science so fun and accessible. And I will always be grateful to her for that. And then as I've continued from my career, I basically jumped from fantastic role model to fantastic role model. So my undergrad advisor, Claire Ting, was just a font of energy and excitement about science. Then my PhD advisor, Jekka Wang, he has this gift for getting you really inspired. So I mean, science is disappointing and frustrating. And I'll get in kind of a slump and then I go and talk to him and he just rejuvenates my energy. And I really admire his excitement and his curiosity and his passion for science projects that are very different from his own.
Mm.
And I really admire that about him. And then, of course, I have to mention the physician scientists who I've really modeled my career on. In particular, there's this guy named Rohit who is in my gap year lab. And Rohit is so humble and so approachable, but so brilliant. And he's the sort of person who would, he's very, he's he doesn't stand on a pedestal. He gets right down next to you and talks to you, whether you're, I mean, I've seen him talk to 5-year-olds with more respect than many adults treat each other. And I really found him approachable and available in a way that I never known a physician scientist to be. So he's been really transformational in my career.
Thank you. So you mentioned sort of like the aspect of like science communication and also being able to like kind of ask for help or have like inspiration and motivation from um, your mentors and like people who inspired you in your career. Is that correct?
Yes.
Okay. All right. Sort of coming back to what you do right now, could you name some of like the highlights of your profession and sort of what are some of the hardest parts related to your work?
So I will say that science can be deeply frustrating. And even when it goes well, it's a game of delayed gratification. So my PhD was 6 years, and for the first 3 years, I felt like I wasn't making any progress at all. And I only got negative results or the experiment didn't work to begin with. And I just couldn't get my grip on the project. And it really wasn't until I moved into the Weng Lab that I started to feel like I could really take ownership of my project and understand what I was doing and why. And I think that, and even now, I mean, it's been 3 years after that, so 6 years total, I finally feel like I have a story that I'm ready to share with the world. And even now, like this is so my research, I study bitter taste receptors in amphibians. So it is very basic. It's not what I expected to do as an MD PhD at all. But I love how exciting and creative the project has been. But I know that so I had an Uber driver the other day who asked me what I was doing. And I explained my project. He said, that sounds interesting at all, but why does it matter?
Mm,
And so sometimes you can feel like my entire PhD has been producing this paper, which is of intense interest to maybe 20 scientists in the world. Um, Most people don't understand why what I do is cool. Or they say like, oh, frogs are cool. And that's kind of where their interest ends. So I would say like one of the real downsides of science is that you become an expert of a niche that most people don't care about. And it can, even when there is application to everyday life, it can take decades to come around and make a difference. And I would just add that part of the reason I want to be a physician scientist is because I think that the strengths and weaknesses of medicine and science balance each other really well. Because medicine gives you that constant feedback that, like, yes, today I did a good job. Today I helped somebody. Today I made a difference. But the downside of medicine is that it's much less creative and there are fewer opportunities to explore and try new things and to really stretch yourself as a person. And so I find that the strengths and weaknesses of these two halves of my life really support each other and allow me to continue through the tough times in each field.
right. Okay, so just to summarize, you feel as like your scientific research allows for more like independence and creativity that maybe the medical field doesn't really allow you, but you do see more of like a direct impact and like change and like in your everyday life when you engage in that part of science as well. So that's why you sort of chose both careers, or is that
That's an excellent summary.
okay? Okay.
Um, I would say that I'm still figuring this out. I still think about what I want to be when I grow up, and I'm in my early 30s. So I would say that choosing to become a physician scientist means you have to be comfortable with a certain amount of suspended decision making.
Mm.
And you have to be comfortable with being a trainee for part of your life when most of your classmates are settling down and getting job security and getting fancy titles after their name. And it's the downside.
You mentioned like after like your work comes out, maybe there are like 20 scientists who are like actually interested in it. Despite that, but for like our viewers, is there anything exciting or yeah, any exciting like scientific advances in your field currently that you would like to share with us?
Yeah. So I would actually say this is a really exciting time to do what I do.
Mhm.
So most of what I do involves I take new genomes that we haven't studied very well yet. So the three-toed sloth or the mallard duck. I take some exciting new genome that just became available. And I look for the bitter taste receptors in that genome. And I can do a lot of cool analyses based on what the receptors look like, where they're located, how they're arranged, that sort of thing. Um, and this is only possible now because so many labs are generously contributing their genomes. So we've gone from, I mean, the first vertebrate genome was sequenced a couple tens of years ago, the Human Genome Project in the early 2000s. And now for my project, I had access to 1,000 vertebrate genomes. And that's really all come about in the past couple of years. And it allows us to do computational biology in a way that we never have before. And I think that's tremendously exciting. And it means, my first 3 years, I was a wet lab biologist. I was in there pipetting and running experiments and doing that sort of thing. I have come to really love computational biology because you can work with somebody else's data and you can ask a question and get an answer much faster. And you can only ask certain types of questions. You can't always ask functional questions. You have to collaborate with somebody to get those functional answers. But the wealth of computational data that has become available and broadly shared with the scientific community makes for very exciting and very rapid science.
Thank you. Okay, so like moving more onto what like this platform is centered around, which is visibility of women in STEM. Could you just share some of your thoughts about representation of women and gender minorities in STEM and how you believe diversity and inclusion can impact innovation and progression in STEM innovation?
Yeah, so I would say I think representation is critically important, and we've made some progress, but maybe not enough. So in my field, which is biology, um, we have pretty equal representation of men and women among trainees,
Mhm.
but it decreases as you go farther up the food chain. So the people who are tenured faculty are still disproportionately men.
Mhm.
So I work at MIT in the building, the Whitehead Institute. And for when I started in the lab, there were more principal investigators with the name David than there were principal investigators who were women. And that was really demoralizing. And it meant that if I wanted advice about how to construct a career as a woman in science, there were very few people for me to turn to. And the few people who there were terribly overworked because they were answering questions from, half the trainees. And that made it hard for them to advance in their own careers. So I would say, but that's really started to change largely because we have a new leader. I loved our last leader. Our last leader was great, but our new leader is Ruth Lehman, who is a really strong female PI and a strong female leader. And she's really made an effort to recruit heavily among women and gender minorities at all levels of the process. And I've been told that she really makes a much more welcoming environment for female PIs. And it makes it easier for them to get a start and to really thrive, so that people not just visit us for a while, but they actually settle down and stay and establish careers. So I would say, I think it's really important to have representation at every level of the process and not just at the beginning. And I think it's really great that we've done a good job of encouraging women to go into biology. And that's a great start. But now we need to work on keeping them there so that they can establish careers and do other activities in their life. So another common barrier that I see a lot is women in our society still carry the bulk of the work for raising children.
Mhm.
And because it is very hard to raise children and run a lab, many people don't decide to become principal investigators if they want to have children and are women. And even at this point in my training, it was only 2 years ago that I met somebody who was a principal investigator and a primary parent. Out of the dozens of faculty I've talked to, I can name one. And he's a man. So
Okay. Yeah, I like that you mentioned that, when you can focus on diversity and bringing in, diverse voices at the table and within spaces, but it's also really important to have the support that people can thrive in those spaces, and you have that sustained diversity and inclusion, and also the fact that we sometimes overlook that society puts most of the caregiving work on women, and the scientific fields don't really accommodate that very well, and um, we need more support in that manner. I guess, could you describe any challenges that you faced as a woman in STEM and how you overcame them?
yeah, I would say the first problem I would describe is difficulty finding roles.
Mm.
And I have really solved this problem by making patchworks. Instead of saying, I want to be just like Ashmita, I would say, I want to be like Becky in terms of activism, and I want to be like Claire in terms of research scope, and I want to be like Roberto in terms of parenthood.
Mm.
And I have to kind of build these collage identities of who I want to be based on specific characteristics. Whereas many of the men I know can then just say, like, oh yeah, Bob is everything I want to be. And they can just aim to be like Bob. And it's a little harder for us. And I understand that's also hard when you add in extra challenges. Like, I identify as a person with a disability. So I also have to find role models about how to live with disability and how to be a scientist with disability. Folks who are non-white or weren't born in the US. And then the intersectionality really adds here. And you sort of have to make kind of composite role models for all these different aspects of your life. So I think that's one challenge. Another challenge that I would be remiss if I did not mention, there are, in any career in which I have friends that I trust, there exists a small number of toxic workplaces. And I know this for finance, for science, for teaching, whatever. And there also exists a small number of workplaces that are uniquely toxic to women or non-binary folks. And these workplaces may have sexist bosses or bosses who harass. And I will say that because of the power structures of academia,
Mhm.
it can be very hard, and harder than it should be, to avoid these situations and to recover should they affect you. And I'm lucky in that I haven't experienced this directly, but some of my friends have. And the advice I would give there is to talk to older mentors and older colleagues so you can try to spot these situations from the outside. And if you do find yourself in a really toxic situation, whether because of gender or some other factor, get help early
Mhm.
and reach out, talk to people in your network, talk to trusted mentors who have a little more objectivity, and get the support you need to get out. And I did mention that I switched labs. It was not because of this, but I'm really grateful that I had mentors who supported me when I was making what seemed to them like an illogical choice. And I think that it's important to, it's particularly important for folks who belong to underrepresented categories of any sort to have mentorship and to have supportive mentors who understand specifically what it means to be a woman in STEM, a non-binary person in STEM, any insert whatever minority group you want here. And it's really important to have that advising.
Yeah, thank you for sharing that advice and also previously mentioning that when you look at role models, it's sort of like patchwork and seeing which sectors of your life certain people sort of inspire you in. Whereas within like for yeah, I think that's most of it. Is that correct, right? Um,
Yes, good, again, a good summary.
Okay. Um, I guess I want to move on more onto like an institutional and organizational level. I know right now you mentioned that the director of the Whitehead is doing a great job in sustaining diversity within the workplace. But as we know, there needs to be more work done within DEI in like an entire level to increase visibility and also inclusion. Um, and equity within STEM, what do you think are some steps that these places and environments can make so that we have more inclusive spaces for women in STEM?
Um, you already touched on this, but I think having women in leadership is extremely important. But I would also say having a critical mass of women and non-binary researchers such that not all of the DI work falls on any one person. Because we currently have this messed up setting where we recruit a small number of women to institutions and then we expect them to be on every single committee. But we don't reward them for being on those committees. We say, why didn't you get more science done?
Mm.
And then when there's a tenure review or you're up for promotion or you're applying for a grant, all they see is that you didn't get as much science done as your male competitor. And I think the way around that is to A, have enough women that you can spread it out. And B, I think we need to more materially reward people who participate in DEI and other community service activities. Because those should be seen as progress in your career as well. And I think that's overlooked. So I think this fits into a larger narrative about women doing a lot of unpaid and unappreciated labor in our society. And it's just as true in the workplace as it is at home, unfortunately.
Ah,
Um, so I think that's a really big one. One thing that I'll say that Ruth has done that I wish other groups would emulate.
mhm.
Um, Ruth has led the board in creating a very large fund of money to support DEI activities. And I'm part of a couple of these groups, like I came in contact with you through the women's group. But so this is a group that has a fairly large annual budget, and we can use that to on any way that promotes the wellness of members of that subgroup in our community. So I'm part of the LGBTQ group as well, and we spend our budget on everything from making signs to go to Pride, to movie nights, to inviting speakers to come and talk, and then reimbursing them for their travel and giving them an honorarium as well. So this money can be used for anything from network building to quality of life to supporting the careers of other folks in our community. And I think that Ruth's generosity in terms of what she has given us has really given us, it's helped us form these communities, form these support networks, and put all of the affected parties in the same room. And I think that's been really important.
Thank you for sharing those answers. I don't actually believe I've heard those answers before, especially about materializing rewards and also moving on into like more financial support in DEI initiatives. So thank you for sharing that. I guess How do you believe that like visibility of women in STEM and gender minorities in STEM or any marginalized group in pursuing a career in STEM affects the aspirations of those looking into those careers?
I think that when I was growing up, all the scientists I knew, with the exception of Becky, were all men. And I could imagine myself being like them, but it required more imagination and more creativity than I think my other male colleagues had to do. So like I would have to say, like, I'm gonna be like them, but I'm also gonna be a mom. And I'm gonna be like them, but I'm not gonna dress the way they do. And it's just there were all of these obstacles to seeing myself doing that thing, and places where there were unknowns, and there's a little bit of anxiety that crept in about what's my life actually going to be like, because and what does it mean that I don't know anybody who does what I want? And I think representation gives us tangible role models, but it also gives us a path to get there. And having multiple role models and multiple examples of who you want to be gives you a sense of security. And it kind of shows us that there are many ways to get where you want to go. And you don't have to walk this little tiny tightrope. And if you fall off either side, you're a failure. Having multiple role models with multiple different life paths shows that there are many paths to happiness and to success in this career. So again, to emphasize, I think it's important to not just have one role model, but to have a little army of people you admire so that you can see many paths get in there. And I think gender is a really important dimension for this. So having female role models, having non-binary role models, trans role models, however you identify, whatever you're looking for, seeing yourself reflected in the career you want can help you start to figure out how you need to grow and what skills you need to have in order to get where you're going.
Thank you. I guess moving on to our last question, going back to like earlier in our interview, um, about like your career to get where you are right now, just reflecting on, that trajectory, what is some advice that you would give to your younger self? And then also what is some advice that you would give to our viewers right now? Sorry.
I would say two things. First, I would say don't be discouraged if science is challenging or math is challenging. I would say everybody I know who is a scientist found some part of their training very difficult. Some people had trouble early on, like, they found calculus hard and they had doubts about, like, can I be a scientist if I kind of struggle with calculus? Some people have an easy path until they apply for their first grant. And then they're like, oh my gosh, I don't know how to write. How do I write a grant? How do I do this? But everybody I know well enough to ask has had some part of the process where they've doubted whether they have the right skill set.
Mm.
And I would say that just because what you're doing is hard doesn't mean you're not meant to do this. And struggling is part of the process, but it doesn't have to be miserable. And for me, going through the hard parts, when I can kind of separate out the, like, yeah, this is hard, from the self-doubt, if you can subtract out the self-doubt, then the hard work is much easier to sustain. So that was my first bit of advice, like, trust in yourself and don't think that you're doing the wrong thing if it's hard for you. And then the second thing I would say is build skills that aren't directly related to STEM as well. So everybody talks about how scientists have to be good at math. Well, that's helpful. That's definitely true. But I would also say that scientists have to be good writers. And this is something where a lot of my friends are really taken by surprise, because they've gone through their entire career and they're like, yeah, you're good at STEM, you're going to make a great scientist. And then they're like, okay, now I have to write a paper, or now I have to write a grant, or now I have to write my thesis. And they just get overwhelmed by the amount of writing they have to do. I'm really lucky. Since my dad is a mathematician, he told me very early on, Kate, you need to know how to write. So I really worked hard in my English classes and in my humanities classes in high school and college, and I got to love writing. And I think that's really served me very well. I would say that learning is never wasted. and build skills with as much as you can, and they will help you.
Thank you so much for sharing that advice. And thank you so, so much for being here. It was a pleasure and honor talking to you today, Kate.
Thank you very much.